Let us resume with the side angle inequality conjecture. Here's what we're going to do. I want you to label this maybe a 4 over here. I want you to label this a 6. And I want you to label this as an 11. 3 sides of a triangle. Now, how do these relate to the angles? I want you to think about if you are opening a door, but as you're opening this door, you are going to stick a string between the edge of the door and the door frame. So like a string is attached to the actual door itself. And if I was to open the door just a little bit, the length of that string is not super long. But if I was to open the door all the way, the length of that string gets really long. That's basically what's happening with the side angle inequality conjecture. Ready? The smallest angle is opposite the shortest side. And turns out the largest angle is opposite, you guessed it, the longest side. So in this example we've drawn up here, if I was to, let's call that ABC. Ready? Dora the Explorer moment. Which angle is the smallest angle? C. Yes, very good. Now, here's what we mean by opposite. If you didn't quite get that, that's okay, because maybe you didn't know what it meant to be opposite. That's opposite. Smallest angle, opposite. Meaning I go all the way across the triangle to get to the other side. So let's try again with the second one. Which angle is the largest angle of the triangle? B. Great. So that's the largest angle because that is opposite the longest side. So let's come over here to our example. Order the sides of each triangle from shortest to longest. Well, if I want to find the shortest side, I need to find the smallest angle, which I see is angle S. So that means opposite that is side length TU. Great. Well, the next one is going to be my 60 degrees, which is opposite side ST, which leaves the longest side with the largest angle of SU. And that's pretty much all it takes. If you come to part B, you see that, oh crap, I have 2 angles that are congruent. Well, here's what I know. Both of those sides have got to be the same length because they're across from the same size angle. So that means I can just say LK and KM, and then I can pull in this other side LM. And that's all it takes, is just an and in between. That's pretty much it for that concept. I would encourage you to try part C. How about now order angles in each triangle from smallest to largest. Smallest, that means I need my smallest side, which is right there. Wabam, angle D. Next side, 18. Look at that. Angle E, which means angle F remains, and we definitely understand this concept. You thought you would escape puns because I wasn't there? You were wrong! Okay, moving on to another example. Smallest side, smallest angle. Next smallest side to next smallest angle, and largest side to largest angle. And that's all that takes. Hey, You see that 10.2 down there? It means we're almost done. So let's do our last little bit. Just a refresher about isosceles triangles and equilateral triangles. Isosceles, here's what you got. Two sides, let me erase that real quick. Okay. I know that two sides are congruent. And I know that two angles are congruent. And that's what these markings mean. That means congruent sides. This means congruent angles. So if I was to come to example B, for instance, I'm trying to find this angle down here. Well, what do I know? I know that these are two congruent sides. And something that I want to be specific of is that the two congruent angles are the two angles that are not the meeting point of your two congruent sides. So this, because you see how these are my congruent sides which meet at the 30 degrees, or those two congruent sides meet at the top up here. So that means the other two angles are the ones that are congruent. So if I know that this is x, that also makes the other corner x. Well, what do I know about all angles in a triangle? They have to add 280 degrees. Great, now I just solve for x. 2x is 150. Divide them both by 2. X equals 75. Nice. I would encourage you to pause the video at this time and try part C on your own. Maybe you didn't get very far, and that's okay. But once again, see how here are my two congruent sides, which means these two base angles are congruent, which tells me that's a 46. So I know that 180 is x plus 46 plus 46. So if I just subtract all that together, 180 minus 46 minus 46, we get 88. And let's not forget lovely part D here. Those are my two congruent sides because they did not meet at the congruent angles, which means that x has to be 11. Okay, so that's isosceles triangles. Let's talk about equilateral. We have three congruent sides. And we have three congruent angles. Well, hey, if I know that all of these angles have to be congruent, well then each angle is just 180 divided by 3, which is 60 degrees. Every single angle in an equilateral triangle has to be 60 degrees. That's just how math works. So part A, what do you think x is? I hope you said 60 degrees out loud. That would make me so happy. Okay. Oh, what about, look at this getting tricky up here. Measure of angle 2 is x plus 69. Well, I see from these markings, it's equilateral. So that tells me that x plus 69 has to be 60. Now we do the quick maths. And we get x equals -9. Part F. How do we know that this is an equilateral triangle? Oh, it has 3 congruent angles, which means there have to be 3 congruent sides. If they're congruent, that means they're equal. 9 equals 2x minus 7. 16 equals 2x. Divide both sides by 2. X equals 8. And that concludes our journey through 10.1.